Hi scholars, it's Mrs. Avedian. I'm going to go over your packet pages 11 and 12 today. So on pages 11 and 12, you're really doing what we've done in class and as homework on generating equivalent expressions by combining like terms, and applying your properties. These first few, I'm gonna do every 5 problems to show you how to do them, and then you also want to pay attention because I might tell you some problems that are optional and that you can skip. Okay, so question 5 here. Question 5, I have always do your parentheses first. So 1 plus 1, it's just 2. 1 plus 1 plus 1 is 3, and 2 plus 3 is 5. So your answer is 5. Okay, that's pretty straightforward, pretty easy to do there. Let's scroll down, and now we're going to do number 10. And number 10 and number 5, you see, look almost identical, except number 10 has x's instead of 1's. So if I have x plus x, how many x's do I have? I have 2 x's. And if I have x plus x plus x, how many x's do I have? Well, there's 3 x's there, because they're just being added together. And 2 x's plus 3 x's is 5 x's. Or 5 times x, because repeated addition is also known as multiplication. Okay, let's come down to number 15 and look at number 15. Number 15, we have 7x plus x. So we have 7 x's and we're adding another one. So that gives us 8 x's. Okay. Let's come down and look at number 20. We have 10 x's and we're taking away 10 x's. So how many do we have left? That is going to be 0 x's. We have nothing left. We have 0 left. We took it away. Okay. Now let's come up here and take a look at question 25. 25 is the first time we have terms. So when we're looking at these, here are terms. Terms are separated by your pluses and minuses, or your addition and subtraction. So if I draw a line right in front of the addition or subtraction symbols, each one of these is a term. 7x is a term. Negative 2x or minus 2x, they both mean the same thing, is a term. Plus 3x or positive 3, not 3x, just 3 is a term. I can only combine the terms that have the same variable raised to the same power. Can only combine terms with, I should have left myself more space. Here, I'm going to make this interesting. The same variable and power. Okay. This is an exponent. So I can't combine them unless they're the same variable raised to the same power. So I can combine the 7x's and the negative 2x, but I can't add the 3 in. So 7x minus 2x, or 7x and negative 2x's, is going to be 5x's. And then I can't do anything with this. Okay, so it's 5x plus 3. It is not 8x. Not 8x, because this is 3, the number 3, it's 3 1s, and this is 7 x's and 2 x's. We don't know what x is. It could be 7 5s. It could be and negative 2 5s. It could be, x could be 3. It could be 7 3s and negative 2 3s. It could be 10,000. It could be 7 10,000s and 2 10,000s. Okay, let's keep moving down to number 30. Now see, number 30, we have to be careful because we have 4 x's. We have the sum of 4x and 3 here, and then we're adding another 6x to it. And inside the parenthesis is the 4 x's and the 3's and the 3 1's. I cannot add those together. However, our properties tell us, our commutative property tells us that this is the same as we can move this stuff around. So this is the same as 6x plus 4x plus 3. Okay, I just flip those around because 2 plus 3 is the same as 3 plus 2, right? And we also know that 6x plus 4x in parenthesis plus 3 is the same as 6. So because, think about this for a second. Let me grab another piece of paper. Okay, so I was saying that it doesn't matter what order I do these in. I can do these first, and then I can add these up and then add this, or I can add these up and then add this. And I'm going to show you an example of why that works. It works because if I were to have 2 plus 7 plus another 5, okay, that's going to be 2 plus 7 is 9, plus another 5 is 14, okay. This is going to be the same as if I took 2 and added it to the sum of 7 and 5, okay. 7 and 5, 7, 8, 9, 10, 11, 12, okay. So I have 12 here. I have a 2 here. 2 plus 12 is also 14. So it does not matter. The general rule is that if you have all addition or all multiplication, it doesn't matter the order in which you do the multiplying or the adding. So since I have all addition across here, it doesn't matter what I do first. I'm always going to get the same answer. Let's go ahead and move on to the next one. Now, my paper from here on out is going to have most of the answers on it, but I'll still walk through with you what I did. So on number 35. On number 35, let me rewrite it on my page here so that you can still see what took place. So 3x, and it was minus 9. Okay. And I'm going to add to that 3x plus 5. Okay, so I've got a few things I can do here. First of all, I could start rearranging things. Okay, so I could flip over this 3x and this 5 so that the 5 is on this side closer to this negative 9. But I told you that the rule is that as long as we have all addition or all multiplication, then we can use any order, any grouping. So what could I do to change this subtraction to addition so that I had all addition? Let you think about that for a second. Okay, so in math class, we learned when we were in our last module that adding the opposite is the same as subtracting. So if I'm subtracting something, it's the same as adding the opposite of it. So I can change this to adding negative 9, and now I have all addition, so any order, any grouping applies. So I can take these two 3x's and I can add those together, and I'm going to get 6x's. And then I can take my negative 9 and I can take my 5 here and I can add those together. So negative 9 plus 5, they have opposite signs. So I'm going to take the difference between them. So 5, 6, 7, 8, 9. Okay. So the difference between them is 4, and it's going to get the sign of the number with the greater absolute value. So 9 is farther away from 0, has a greater absolute value than 5, so it's going to get the sign of that negative there. And these two things were being added together. So I could write it as -4 plus 6x. I could write it as 6x minus 4, or I could write it as 6x plus -4. All of these are correct ways to write that. Okay, now let's go take a look at the rest of this page. So you've got some decimals here. You are welcome to use a calculator to add up the decimals. This one has decimals as well. Then you have some fractions. I really challenge you, these next 5 problems, I'm going to call challenge problems, and I challenge you to try them using the rules for adding fractions, because that's something that you're going to use a lot of when you get to algebra, is adding fractions, especially like these with unlike denominators. All the rules we just used up here still apply. They're just fractions now. So I challenge you to do this by hand without a calculator, and then check your work. Okay, after you do it by hand, check your work using the Desmos Scientific Calculator. The Desmos Scientific Calculator has a little button that looks like this next to the answer. It's a little circle next to the answer that looks just like that. And if you click on that, it'll switch your answer to fractions, so you can check your work and see if you did it right. You know, challenge yourself even to do just one of those. Okay. Now we have page 11 that is exactly the same as page 12. So as we look through these, let's go ahead and look at these. So your first one, oh, if I can get my page centered correctly. Okay. So number 5, if you want to check your work, we have 6 ones here. Because it's all addition, you can add them in any order with any grouping. It doesn't matter what you add first, second, third, fourth, if they're all addition. So that's 6 ones total. Okay. Number 10, just because it's x's doesn't mean that the same rules don't apply. You can add in any order with any grouping. So you still have 6 x's. Number 15, you have 1x. You notice there's no 1 sitting in front of it. That's because why would we write a 1? If we have an x there, we know there's only one of them. So we don't really need to write the 1. So we have an x here, and then we have 8 x's. So together, those are 9 x's. Okay. Number 20, be very, very careful. This is 2 x's minus 3 x's. It is not 3 minus 2. So you have 2. You're taking away more than what you have. So the difference between 2 and 3 is definitely 1. So that's where our x comes from. But the number with the greater absolute value is the 3. And the sign in front of that 3 is a subtraction. So my answer is negative. You can use a number line if you need to. Okay. This one up here, number 25. We have 7 x's minus 4x. So together, that is 3 x's. And then we're adding 5 to it. The 5 does not have a variable on it, so we cannot add it in there. We don't know what these x's are. They could be, each of those x's could represent 1,256. So that's not the number 7. That's 7 of whatever this x has to be. So we have 3 x's, and we're still adding 5, which is 5 ones. This is your answer. You don't have to go any farther than that. You're just being asked to simplify, not calculate or evaluate. Okay. This next one here, I did earlier when the camera wasn't rolling. So what it says is 9x minus 1 plus 6x. So we know that we can ignore these parentheses if all of this is addition. So we can change subtraction of 1 to adding the opposite of 1. Now we have all addition. So now we can turn around and ignore these parentheses. Okay? Because we can do any order, any grouping. And I want to put this 9x and this 6x together first to get 15x, and then I still have this plus -1 left. Or I could write it as 15 minus 1, because 15x minus 1, because minus 1 and adding -1 are the same thing. Okay. Now let's come down here to number 35, and we've got the same situation with number 35. We don't have all addition across. We have subtraction here, but that is easy enough to solve by saying I'm going to add the opposite of 2 instead of subtracting it. So now I've got 5x's and 2x's over here. I can go ahead and put those together first. 5x's and 2x's is going to be 7x's. And then -2 and the number 5. Okay, the difference between 2 and 5 is 3. Okay, because 2, 3, 4, 5. And then the number with the greater absolute value, the 5, has a positive in front of it. So my 3 is going to be plus 3. Okay. Now let's go down to number 40. Number 40 is decimals. The rules still apply, and I want you to be careful because I have x's. First thing I would do is change this to all addition so I could ignore my fractions. Plus -3.8 or 3 8/10 y. The next thing I would do once I did that is I would look for my variables. So this is an x and this is a y. I cannot add those together. I have 9.7x or 9 7/10x, and I need to, the other x I've got is a -2/8x. So it is okay if you want to use a calculator to put those together, or you can do it by hand. So I'm going to do it right here on a scrap piece of paper. I have 9 7/10, and I'm taking away 2 8/10 x's. These are both x's. You notice I lined up my decimals because when you're adding or subtracting decimal quantities, you need to line up your decimals. 7 minus 8, I cannot do that, so I need to regroup. I need to take 1 away from here, and that gives me 17. So 17 minus 8 is going to be 9. I'm carrying my decimal right down with me. 8 minus 2 is 6. So 6 9/10. So in this problem, 6 9/10 x. Okay. And now I've got my -3.8 y and positive 4 5/10 y. Okay. So I want to put my positive number on the top, 4.5 y, or 4 5/10 y, and I'm taking away that negative number, minus 3 8/10 y. Again, I lined up my decimals. 5 minus 8, I need to regroup, so I need to take one of these 10s away. 15 minus 8 is going to be 7. And I need to carry my decimal down. 3 minus 3 is 0. And these are y's, just like these were x's. So this is plus 7/10 y. Okay, just so you get the idea that these are exactly the same, even if you have decimal quantities. Numbers 41, 42, 43, and 44 are optional. But I challenge you to do them by hand and then check your work. You know, getting the practice never hurts. Also, if you are really struggling with this and it takes you more than an hour to do these 2 pages, then you need to give me a call so that we can discuss what is going to be the best assignment for you personally. We can personalize these assignments if need be. It is, you know, it's about learning and spending the time and investing the time and your brain power and growing your perseverance when it comes to math. It's not about just getting the page done. So please, please, please reach out to me if you are struggling, need additional help, or if you need me to adjust the number of problems that you have to do on this assignment. Keep up the good work, kiddos. I'll post another video soon.